Good afternoon, everyone. Welcome back to the session 12 of ATAL FDP program. And we are having Dr. Abhilash Pochiraju garu with us now. And Sir has is expertise in programming and development like Python, SAS, Java, JavaScript, SQL, and many more. Cloud and develops, data science and AI, data visualization and analytics, software development and leadership. Sir's professional experience as a senior data scientist led the development of scalable machine learning pipelines, optimizing data extraction and analysis for key business decisions, superheaded the integration of LLMs to enhance user data processing and backend external service interactions, also developed backend APIs and predictive models driving operational efficiency and automation. uh, Also, Sir, I was in data science engineering players lounge from Feb 2023 to April 2023. Designed and deployed an interactive R Shiny web dashboard for real-time business analytics and P&L tracking. Also led data scientist Technopoint Limited of March 2021 to November 2022. Project manager Parianshi Software Solution Private Limited at on December 2020 to Feb 2021, and led AI-led Fungex Private Limited November 2018 to September 2019. Was consultant, founder, CEO, Analytica Business Solution Private Limited. Also many more. And Sir has a master's degree data analysis for business intelligence, and Sir built and managed high performing data science teams, scaling project delivery capacities, and successfully founded and grew a consulting firm, acquiring high value clients and delivering strategic insights. Also, Sir has given public speaking and training, conducted corporate AI and data science workshops, and many more. Thank you, Sir. We are delighted to have you with us today. I request you to take over the session from now.
Okay, ma'am. Thank you very much. So is my PowerPoint visible now? Is my screen visible? Like, is the
Yes,
presentation?
sir. Yes, sir.
Okay, thank you very much. Okay, so let me just give a brief explanation about the sustainable energies as I have researched about them. For the sustainable energies part. So let me just give a brief on this, and then we will continue. I am going to speak about how data science can be useful in sustainable energy domain or field. So sustainable energies, as everyone here knows, are comparable, are called renewable energies because they do not affect the future generations. Sustainable energy basically refers to any kind of energy which can be used today and it would not affect the future generations' needs. And I believe that the sun, basically the sun is the ultimate source of any renewable energy. So this is just a small um, overview of sustainable energy and its development that I've prepared since 1800s. So before the industrial era or in 1800s, in general, everyone used wood for any form of energy requirement, and watermills and windmills were used, but then they were very small in size. In 1900s, there was an increase in the usage of hydropower or tidal power generation, and Hoover Dam is one of the best for it. Then in 1950s, the nuclear energy was introduced, and of course, it was very widely uh, what do I say? It was very widely accepted, but there were a lot of doubts about it because of the accidents which came before that. And as you can see, after that, in 1970s, there was a rise in environmental awareness, and the solar, wind, and geothermal energy slowly started increasing. After that, as you know, is the current era where we are using all of them. So these are the same things which I was talking about just a minute ago. During the Industrial Revolution, coal was the most dominantly used energy source. And during the 1900s, again, petroleum or oil took over the coal as the primary source because of the development of cars and other automobiles. Now, during the past 20 years or 30 years, the awareness of global warming and the climatic changes has increased. And because of that, there are a lot of policies being introduced by the governments, or if you can see, or if you can remember, there was an environmental movement gained because of a publication in Silent Spring, and in the 1980s, the vulnerability because of fossil fuel dependence was also highlighted. Now, in the current era, the renewable energies are, or the renewable energy sector is the fastest growing sector because of net zero rules and zero or net zero carbon reduction and all the other things. Now, the challenges ahead of us in the sustainable energy domain are the intermittency of the required energy. Because the solar and wind energies, when used extensively, still do not contribute to the 100% of the energy requirement. and we do not have enough or sufficient storage for the energy which is produced. The transmission infrastructure for the renewable energies is the same as the actual power grids or the grids or transmission infrastructure that we use in the non-renewable energy sources. So this affects uh, the capability of the production center to actually transmit the entire produced energy to the common population. And since we use minerals like lithium, cobalt, and rare earth elements for the solar panels or other um, energy consuming or energy producing um, infrastructure, the sustainable mining for them is still not good enough for 100% usage. The consistency of policies around or all over India as well as the world is sorry, the consistency of the policies is not same. So it is very difficult for everyone to maintain a proper and consistent energy production and transmission policy. Now, most of the people probably know, but the green hydrogen is, or the hydrogen form of energy is actually the best after nuclear or before nuclear. Both of them are very good for the future. So this the particular slide here shows the outlook for the future. Now, uh, the first the first one is the solar energy, in my opinion, which is most widely used in India right now or all over the world right now. But the problem with solar energy is that it takes up huge amount of space to set up the solar farms, and the the raw material required for producing the solar panels is still not sufficient enough for it to be used extensively all over the country. So this is just a small, sorry, this is just a small timeline of the solar energy usage in India. So the first two parts, which is from 1970s to 2000s, the 30 years, was actually early R&D and uh, basically independent off-grid solar production, the solar energy production. After the launch of Jawaharlal Nehru solar mission in 2009 and 10, the policies were actually created which helped in the development of uh, the the technology required, as well as it was declared as a priority in India. And later on, as years went on, we actually increased the wattage which was produced, and since 2023 to the present date, we have a target of 280 gigawatts of solar energy to be produced by 2030, while pushing for hydrogen manufacturing. Sorry. Again, the next one is hydropower generation or tidal power generation, which was actually started, which the first hydel power plant in India was set up in 1897 in West Bengal near Darjeeling. It had a capacity of 130 kilowatts, and later on, after 1897, from 1902 to 1947, until the independence, there were several small uh, plants built, mainly in the Himalayan region and the southern India, where there were a lot of tea estates for railways and for irrigation purposes. The notable uh, hydel power plants before independence or pre-independence were Shivanasamudra plant in Karnataka and Kunda scheme in Tamil Nadu, which was initiated in 1930s. After the independence, since 1947 until the 1970s, there were large multi-purpose river valley projects, of which the major projects were Bhakra Dam, which is located in Punjab and Himachal Pradesh. It was commissioned in 1963. Then Hirakud Dam in Odisha, which was commissioned in 1957, and the Damodar Valley project in Jharkhand in 1950s. And all of these projects were emphasized to be under public sector ownership, which were basically the agencies like Central Electricity Authority, CEA, and state electricity boards. After the 1970s, from 1980s to the 90s, the capacity increased with both the storage based and run of the river projects. Also, projects like Naptha Jakri, which was in Himachal Pradesh, and Tehri, which was in Uttarakhand, received foreign technical and funding supports. The hydropower generation was prioritized in the 6th and 7th 5-year plans to reduce the dependence on coal in India. After the 1990s, since 91 or since 1991 or 90s to 2000s, basically 1991 to 2000s, liberalization and private sectors were brought into picture for the hydropower generation. In 1991, the economic reforms opened the sector to the private and foreign investment. And in 1998, the hydropower policy also aimed to attract private developers. Also, there was more focus on run-of-the-river projects because they reduce the displacement and environmental concerns, of which the most notable were Tehri Dam in 2006, which produced almost 1,000 megawatts of power, and the Sri Salem Dam in our state, which is also one of the most highly used hydropower generators. After 2010 till the present, emphasis on clean energy transitions have increased, and hydropower renewal projects were classified as less than or equal to 25 megawatt power generators. And later on, they were extended benefits to large hydro powers in 2019. Now, there is a lot of growth in pumped storage projects for balancing the solar and wind variabilities. There is a huge expansion in Northeast India, like Arunachal Pradesh and Sikkim, because they have abundant river resources. After the 2019 hydropower development policy, there has been a large financial support or increase in financial support for flood moderation and enabling the infrastructure required for that. Now, the current capacity as of 2025 in hydropower generation is approximately 52 gigawatts installed hydropower generators, which include small projects as well. Now, as in any other thing or as always, there are a lot of challenges even in hydropower generation. The first and the most important challenge is land acquisition, environmental clearances, and local oppositions to the um, building of different infrastructure. Then the second challenge, which is in general a challenge all over the world, is the sedimentation in reservoirs, which reduce efficiency. Then there are climate changes which alter the river flows. And there is, of course, a competition between the hydropower plants and solar and wind power generation, because the cost efficiency of solar and wind power generation is higher when compared to hydro, which makes them cheaper. So this is what this image is what we have discussed. It shows about all the things that we have spoken. The next thing that we're going to look at is the wind energy. So wind energy is basically, it has the most potential because of the free flowing wind on the surface of the earth. So, most of the people know, wind power generation is, or the turbines use the kinetic energy of the wind to generate electricity. In India, the wind energy generation is the fastest growing renewable sector because it is cheaper and it occupies a lesser area than hydel and solar powers. Also, it plays a very vital role in achieving the country's clean energy targets. So the early development of wind energy, which is the late 1980s to 1990s, India began its wind power programs with the support from Ministry of New and Renewable Energy, MNRE, and international aid agencies. The initial plants, or the first plants for the generation of wind energy, were just demonstration plants in Tamil Nadu, Gujarat, and Maharashtra. The first commercial wind farm was commissioned in 1986 in uh, Verawal, which is in Gujarat. Uh, from 1990s to 2000s, there was a rapid growth in the capacity of wind power generation due to the tax incentives for investors, technology transfers from European companies, and also the state level wind energy policies from Tamil Nadu, Maharashtra, Rajasthan, and Gujarat. In 2003, the Electricity Act allowed private investors or private players and encouraged renewable purchase obligations, which is RPO, which is RPO short form. And the development of wind power generation was so quick that by 2010, from 2003, which is in 7 years, India became the fifth largest wind power producer globally. Now, currently in 2025, we have a 44 gigawatt installed capacity from wind power. The key states for wind power generation in India right now are Tamil Nadu, Gujarat, Maharashtra, Karnataka, Rajasthan, Andhra Pradesh, and Kerala. According to the studies by the Ministry of New and Renewable Energy, the estimated onshore potential is 300 gigawatts and the offshore potential is 70 gigawatts in India for wind power generation. Um, the next part that we have to concentrate on in the wind power generation is the shift from small, which is a 250 to 600 kilowatt turbines in the 1990s, to 2 to 3 megawatt or even 5 to 6 megawatt offshore designs in just a span of 15 years, 13 to 15 years. And currently, there is a huge interest in the development of hybrid projects, which is a combination of wind and solar energy power generation, which would help in optimizing the land usage and the grid usage. There is also a huge leap because of using the digital monitoring equipment and predictive maintenance for the efficiencies of the power generation. The notable uh, incentives or initiatives by the government are the National Offshore Wind Energy Policy in 2015, Wind Solar Hybrid Policy in 2018, uh, both of which helped in promoting the hybrid power plants, the Green Energy Corridor project for the transmission infrastructure, and the most important one, which helped the uh, production of the production of wind turbine components domestically, was the production linked incentive scheme, which has actually increased the production of the components required for turbines and also decreased the prices because they were domestically manufactured by private and public enterprises. Um, the future outlook is very good. Basically, right now India is focusing on offshore wind projects in Gujarat and Tamil Nadu. And we have a target of reaching 140 gigawatt production by 2030 and 500 gigawatt renewable energy goal by 2030. So this is what we have talked about just now. This image in general shows all of that. Now, one of the most important energy production or power production is nuclear energy, which would help us a lot in the future for our next generations. The nuclear energy has almost near zero uh, greenhouse gas emissions during operation. Now, for India, it has been a very long journey in nuclear power generation. The early vision or the foundation was in 1940s or between 1940s and 1960s, when in 1945 the TIFR, the Tata Institute of Fundamental Research, established under Dr. Homi J. Baba, or it was established to develop nuclear sciences. In 1948, the Atomic Energy Commission formed formed or was initiated to oversee the nuclear research and policies. In 1954, the DAE, the Department of Atomic Energy, was created, and it executed the first research reactor It was Asia's first nuclear reactor, and it was a pride of India. It was almost 13 years later, India's first commercial nuclear power station, the Tarapur power station in Maharashtra, was commissioned based on US technology. It was not ingenious, but still it was a very big achievement for India. In the 1970s and 80s, uh, India adopted a three-stage nuclear program to promote self-reliance and indigenous technology-driven power generation. The stage one was pressurized heavy water reactors using natural uranium. The second stage was fast breeder reactors using plutonium from stage one. And stage three was advanced reactors using thorium-based fuel, which again led to the greatest or the first nuclear test in Pokhran, but which led to the international sanctions, again pushing India towards indigenous design and technology. From 1990s to the 2000s, we have, or India has steadily increased the capacity with the standard or standardized 220 megawatt uh, electric hour units. Then the formation of Nuclear Power Corporation of India Limited for the management of commercial reactors helped a lot. And in the late 2000s, India began importing uranium after the Indo-US Civil Nuclear Agreement in 2008, which ended decades of nuclear isolation of India. The recent developments, let's say from 2010 to the present year, we have a construction of the prototype fast breeder reactor at Kalpakkam to enter the stage 2 of the nuclear program, and the international collaborations with Russia, France, and the US, and the increase in on the focus of thorium research, because India has world's largest thorium reserves. And our target as Indian community is we need to achieve net zero by 2070 as a clean energy source. Now, development of nuclear energy reduces the dependence on coal. As always, there are a lot of challenges again. The first one, as I discussed before, is the public perception and the concerns for the safety after the Chernobyl and Fukushima incidents. And the most irritating part or the problematic part of nuclear energy production are its long construction times and very high capitals. Of course, the waste management, again, nuclear waste management is a very complex problem. So this is the journey of India's nuclear energy since the 1940s until the current scenario. The next thing that we look at is, sorry, the geothermal energy. Again, it is not going to um, stand as a or at a forefront of energy production because it requires geothermal heat or hot rock or a magma, which would convert the cold water that is pumped into or onto the rock or magma into a hot steam and then pushed out. But then it can help us manage any difference or excess requirements of electricity or energy produced. Next, here I've put it as hydrogen energy, but I would like to describe this as a green hydrogen big energy. So green hydrogen is basically a type of energy generation where hydrogen is used as a fuel, but the hydrogen is produced by using solar, wind, or hydropower through electrolysis. Hence, there is no pollution after it is burnt because it only produces water. And before production, we don't use any non-renewable source of energy for electrolysis. As you can see on the screen, I have given or I have explained the most hydrogen today is produced from fossil fuels, which are called gray or blue hydrogen. But green hydrogen is different as it is produced by splitting the water molecule using renewable sources. And this makes it a carbon-free fuel. Now, as I said, I would like to call this not just hydrogen energy, but uh, green hydrogen big energy, because or when you hear me saying green hydrogen big energy, it refers to a large scale project or corporate initiatives by big energy companies like Shell or Bharat Petroleum or Reliance or Adani. They are investing a lot in green hydrogen as a future fuel. And governments of European Union, United States, India, Japan, Australia, are at the forefront of launching multi-billion-dollar programs to scale up the green hydrogen production. This is just a process where I've created a diagram or a diagram showing how we can.
స్పీడ్ అయిపోయింది స్పీడ్ నేను కర్రీ తెచ్చియాలి ఎర్లీ వెళ్తావు వెళ్ళాలి
So here we are going to use solar or renewable energies for electrolyzing, splitting the water molecules into hydrogen and oxygen, which can be used or which can be stored and used in transport as fuel cells, in industry, in power generation, and also as green ammonia or fertilizers. Now, why is hydrogen energy important? Because it would help us decarbonize the sectors like steel, cement, or shipping or aviation. Hydrogen also provides, or hydrogen energy generation also provides long-term energy storage, which is beyond batteries. This can also be blended with natural gas and or used in fuel cells. Of course, it supports the global net zero goals, which would generally help, or this would generally help us in becoming carbon neutral economy. The other forms of energy are organic matter, which is bioenergy or biomass. Again, they can be used for energy production, but not on a large scale. We sometimes, even though we produce a huge amount of energy, there are bottlenecks for this or any kind of energy production because of storage solutions. So again, this is what I've talked about. All the governments around the world are coming up with incentives and ways in which they can improve the renewable energy outlook as well as the production around the world. All right, so this was just a brief introduction to renewable energy sources which are sustainable and can be used extensively. Now, the next part, this is a real-time project plan. There are going to be 2 parts of the FDP from now onwards. The first part is that I'm going to show you how we generally put up or create a project plan for any kind of predictive analytics in energy development or energy production sector. This particular project plan is something that I and my team have worked on previously. Of course, this does not contain any confidential data. This is purely for your understanding of or about how we plan a project when we are dealing with a combination of um, hardware and software like energy production and computer science combination. So this particular initiative or the project was to forecast the solar generation electricity demands and then optimize the storage or dispatch to minimize the fossil fuel backup and actually curtail the use of fossil fuels. Just a quick question. Have any one of you worked on any of these kinds of projects before? Theses or PhD theses or research or any of these kind of things? All right. Assuming, ma'am, just a quick confirmation. Is everyone who's attending, are they from the different backgrounds and different subjects, or are they all from a particular department?
Good evening, sir. We are from different departments, sir. I am from CSC.
Okay, so I just wanted to confirm this because some of the attendees might not know how we plan a software development project. Okay. Okay. So there are people from different departments. So the first 2 weeks that we spent, this is a real-time project proposal that we have worked on. So the first 2 weeks were spent on creating the project overview for the stakeholders of the companies. There were multiple companies involved. One of the companies was from UK, and another company was from France, and two more companies from Germany. So there were 4 companies involved with around 17 stakeholders from the client company's side, and there were 3 of us or 4 of us from our side who created this entire project proposal. So the first 2 weeks were dedicated to creating the project overview, and I've put it in a small tabular format here. So the first part was the acceptance criteria for the project. They were the key point indicators which would decide if the project was going to move ahead as a success or a declared as a failure. So the first one was that the forecast for solar power generation would be around 10% MAPE. And does anyone have an idea of what MAPE actually stands for? MAPE stands for mean absolute percentage error. MAPE stands for mean absolute percentage error. So our solar power generation forecast would have a less than or equal to 10% error for a 24-hour production and less than 5% MAPE for intraday, which is like during the same day. If we are forecasting or predicting something during the same day, it would have a less than or equal to 5% error. The demand forecast had less than or equal to 7 or should have a less than or 7 equal to 7% error for the next day, based on which we would actually put in the dispatch. We will talk about dispatch a little later, because we have the second part of the project where I have actually written a code in Python which would predict the dispatch based on the load on the grid. Then the curtailment of the fossil fuels would be greater than or equal to 15% versus the baseline, which is already present. And the backup energy, which was or which is going to be used or produced by you. And the battery throughput improvement should be would decide if the subject matter. The first person that we needed was a project manager who was also a subject matter expert, who could speak the language of the energy or whatever was required in terms of the actual hardware. But we could not find a person who was sufficiently experienced in both project management and as well as a subject matter expert. So we had to hire a person with good project management experience and a subject matter expert who had over 25 years of experience in energy, and we put them together as a team when we were talking to the stakeholders. The second one, or the second role, is was a data engineer, or we actually had two data engineers, a senior and a junior. Again, we had a machine learning engineer, a data scientist, and a data analyst, which is number 5 on the list. All three of them working together. Of course, there were actually two machine learning engineers, two data scientists, and one data analyst. A total of 5 people working together. The optimization engineer and the DevOps engineer worked together. The optimization engineer took care of the scheduling, and the DevOps engineer took care of the CI/CD pipelines. We had a compliance lead and two people under him who were in charge of cybersecurity and data compliances. We also consulted with an expert on data governance, who's again, he had around 29 years of experience as a subject matter expert, and he had over 13 or 12 years of experience as a data governance professional. So this was the team which was proposed for the project. Now, again, this part also comes under the project overview in the first 1 to 2 weeks. We decided on the environment that we were going to use, and also we purchased all the required licenses for the project. So the data part was, again, the database used was Postgres, and the storage was which was used was S3 buckets, because back then we worked on AWS. For the pipelines, we used Airflow. For the machine learning and data scientist or data science part, we used Python with TensorFlow. TensorFlow was for the AI part. And we used XGBoost for the GPUs. For optimization, we used Pyomo. Again, when we were writing the APIs, generally, if you look at any of the Python projects deployed into the market, traditionally, people have always used either Django or Flask. But for this particular project, we have used Fast API because it works faster than Flask and Django. It has a higher efficiency. Of course, it does not have as many features as Flask or Django, but the async or await Python features which are used for asynchronous programming are very good in Fast API. And we used MLflow for all the other things. And for analytics and the business intelligence part, we used Power BI, and we used Git for the versioning. Now, here, the source or the data that we collected were In terms of weather, we collected the irradiance, the cloud cover, the temperatures, wind, and humidity from the local stations, which could give us the satellite data. SCADA is control and data acquisition. These are generally used